What's going on, everybody? Zane here, back with another video. For this one, we're going over question number 875, which is Koko eating bananas. So here, I'll let you guys read this, but basically what we're doing is we need to return some value, and that value is going to be the rate at which Koko can eat bananas, or bananas per hour eaten. So again, our task is to return the optimized, or the minimum, K, or bananas per hour. So we need to give Koko some rate of bananas per hour eaten such that she can eat all, or he can eat, she can eat all of the bananas in the pile within or less than H hours. So how are we going to tackle this? The first way would be the brute force, which is going through all of the values, checking to see if Koko can complete all of or eat all of the bananas, and then set the H value to some, or set the K value to some optimized value. But this would take a lot of resources, and frankly, it is not the optimized approach. So the optimized approach would be using a binary search. And the reason we're going to do that is because we can take a look at a minimum number of bananas she can eat per hour and a maximum number of bananas, and then establish a midpoint. And then depending on how many bananas were eaten and if she can eat all the bananas, we'll either shift our left and right either +1 or -1 from the middle, and then reiterate. So here's what I mean by that. When we're considering binary search, we'll have some value on the left side and some value on the right side. Now, these values are going to correspond to K, which is also our bananas per hour. So on the left side, on the min side, we're going to have 1 banana per hour as our absolute minimum, because Koko is not ever going to have 0 bananas eaten per hour. Otherwise, we wouldn't move anywhere. So the left side is always going to be 1. On the right side, what we could do is we'll just grab the largest value in our pile so that we can assign that to be our fastest bananas per hour speed. And in order to do that, we can technically loop through, but we don't want to do extra time, so we'll use an array stream. So we'll do arrays.stream. We'll stream the piles array. We'll get the max value, and then we'll get the value of the integer. So if we were to look at this example, technically our left is 1 and our right is 11. So now that we have that, we can run our while loop. So while left is less than or equal to right, we'll continuously do a calculation until we get to a point where our left value has been updated so that we can eventually return our left value. So when I say left and right, these are technically going to be our 2 speeds. The speeds at which Koko can eat a banana per hour, or how many bananas she will eat per hour. So don't just think about it as a direction, think about it as the speed at which Koko is going to eat those bananas. So that's why we're going to return left, because the left side will be the value that is most optimized, because we have to keep in mind we do want Koko to eat all the bananas within H time, but we also want it so that Koko can eat it as slowly as she wants, but still finish all of them within the allotted time. That's why it says return the minimum integer. So now that we have our left and our right values set, and we have our while loop started, now we can create our middle section. So mid is going to be whatever left is plus right divided by 2. This is just a standard getting middle of an array. You just get the left side, get the right side, divided by 2, and you're in the middle now. Now that we have our middle value, what do we need to do? Well, we need to check now whether or not Koko can eat all of the bananas. Now, mid is technically our current bananas per hour speed. So with mid, if Koko can eat all of the bananas, then we can do something. So if Koko can eat all bananas in time, then we'll do something, otherwise do something else, and then we'll lastly return our left, because that's going to be our most optimized value. So if Koko can eat all of the bananas what can we do? Well, before we continue, let's actually create this function. So let's go down a bit. We'll create another function. We'll call it Boolean because we just want to know whether or not Koko can eat all the bananas in time. That's going to be the name. And what we're going to pass in is going to be, we'll need the piles. So we'll need some int array piles. We'll need another k value, which is going to be our current value that we're using. So let's just call this bananas per hour, BPH. And we'll create another value called h because we're passing in how fast the bodyguards are going to come back before Koko has to dip. All right, so when we have the signature created, let me just get this out of the way as well, since we're going to have to put it in here. We're going to pass in piles. We're going to pass in mid, which is our current speed, and we'll pass in h, which is our number of hours till the bodyguards come back. So now that we have this, how are we going to tackle whether or not Koko can eat all the bananas in time? Well, what we could do first is we can establish some variable called hours. And we'll set that to 0. And what we'll do is hours till all eaten. Let's just call it that. Now what we'll do is we have this value. We need to get the number of hours it'll take for Koko to be able to eat all of the bananas. So we have to go through every pile in piles. So we go through every single pile of bananas. And now we'll say that how are we going to get how many bananas or how many piles she can eat in a specific time frame. So if we were to take a look at this first value here, we have 3 bananas. So if we gave Koko, let's say we gave her a BPH of, let's say 3. So here, if BPH was 3, that means in 1 hour she could eat 3. Then in here, in 2 hours, she could eat 6. Or in this case, 1 hour would be 3, so she would need another hour to eat 6. So essentially, the value of pile divided by our bananas per hour is going to equal the number of hours that we would need. So let's just call this division. It equals pile divided by BPH. Now, BPH, or pile divided by BPH, is how many hours it would take. So if we just add that to our hours till all eaten, then we have accounted for all of those bananas per hour. Now, if we were ever at a case though, like 7, and if our BPH was technically 3, we could eat 6 in 2 hours, but we'll have 1 left over because 7 minus 6 equals 1. Meaning, if we were to take the value of pile mod BPH, so whatever the remainder of this division is, and if that value does not equal 0, well, we just need to add 1 more hour to our count, because the division has already taken care of the number of hours. We just need to add 1 more just in case there's something left, because even if there's 1 banana remaining and our BPH is 3, well, she's going to take the full hour to eat that 1 left over. So now that we've got our number of hours, now all we need to return is if the hours till all are eaten is less than or equal to the amount of hours till the bodyguards come back, then we can return true. Otherwise, we return false, because it's either Koko can eat all the bananas in time, which is this here, or she can't. So instead of writing an if else, I can just write this as one return statement, which would be return hours till eaten is less than or equal to h. So this is going to tell us whether or not Koko can eat all the bananas in time. So now we can jump back up here. Now, if Koko can eat all the bananas in time, well, if they didn't want us to return the minimum integer or the optimized integer, then we could just return true, or we could just return the value here. But That's not the case. We need to find the optimized value. So now in this case, if Koko can eat all of the bananas in time, well, that means that, okay, it works, but there might be a better number. So all we need to do is set our right value to equal mid minus 1. So we're essentially just pushing our pointer to the left. Otherwise, we'll say that left is going to equal mid plus 1, because if she cannot eat all the bananas, well, we need to increase her rate from 1 to 2, or whatever mid plus 1 is in this case, because we've set that as our current bananas per hour. So I think that's about it. Let's run this, see what we get. So it looks like our time limit was exceeded. So let's take a look at what's going on here. If we were to get the values here, mid, okay, right equals mid minus 1, left equals mid plus 1, okay. The issue might be here, might be causing, there we go. So this is just one trick that I learned, and I'm glad this actually happened, where technically when we're doing a middle of something, we can take the left and the right side and then divide it by 2. That is technically how it works. However, I'm not fully sure why this works, but if you were to subtract the value of left from right, then divide it by 2, that is still technically our mid, and this will also account for any sort of large values. And that might be the cause of this here, but regardless, this is just something I've just burned into my brain about how to get mid if there's any runtime issues. So let's run this and let's submit. And that's it. So just to recap real quick, we're using binary search in this case. We establish our left value and our right value and our mid value. Each of these 3 is going to be the speed at which Koko can eat bananas. The left side is just going to be 1 banana because that's the minimum she can eat per hour. And then the right side is just going to be whatever the largest value is in the piles array. And now, while left does not overlap to right, we'll do some calculation, which is we'll grab the middle. We'll see if Koko can eat all the bananas given the middle. Then, okay, we've got a answer, but maybe not the most optimized. So push right to the left. Otherwise, push left up to the right. And now whatever left is, that'll be our smallest value, or the most minimum integer, or the most optimized bananas per hour. Down here, we created our function just to see if she can eat all the bananas. So we just instantiate some hours variable to keep track of the number of hours. We'll go through all of the piles. We'll say that if we take the pile divided by whatever value of BPH we gave, which is technically mid, then, okay, we'll add it to our hours. And if we do the same thing and the remainder is not 0, well, just add 1 hour to our hours count and return whether or not our hours count is less than or equal to H, which is how long the bodyguards will take to come back. Anyways, guys, that's it for this one. If there's any questions, comments, feedback, please let me know in the comments below, especially if I didn't make something clear. That's something I'm really big on, because overall, this is going to be something that I'm going to look back on, that maybe employers will look back on. So your feedback is really appreciated. Be brutal. Otherwise, I guess I'll see you guys in the next one. Peace.